So the first session, daylight simulation and visualization number 3. And as I said last week, we spent quite a lot of time in terms of daylight simulation, visualization and shading design, because it's an area as architects and as designers that you can have a lot of input. It's also an area where I think the software is quite developed. Okay, let's move into Revit. Now, what we're going to look at this week is how you can look at the daylight simulation for an entire floor plan in the building. Last week, we looked at these two types of simulation and visualization. So simulating a daylight factor, simulating an illuminance level, and also looking at how we might visualize that like this to get a sort of feel for the quality of the daylight in that space. And that kind of image there is probably what we call a kind of qualitative simulation. We're looking at the kind of qualities of the space. We're not, in this example, we're not putting sort of numbers or metrics to that. We're just trying to make an assessment of that space. The three-dimensional simulation that we did after that, we did in that session, it's starting to put metrics. So it starts to be more of a quantitative analysis where we can actually put quantities, so we can put numbers to the simulation. And in this kind of view, we do that by having a color code, and we can align that color code to a legend. Okay. Now we're going to move on today. Zoom all. We're going to move now into looking at how we could run that simulation for a plan view, but also for a whole building type view. Okay, and this is the kind of result that we'll be looking to achieve today. It's not that different from what we did last week, but there's just a few sort of a few fiddly things where it's easy to go wrong. Okay. Now, what we're not covering, in previous years we used to use 3D Studio Max for daylight simulation as well, and I have got some videos on that if you are interested. 3D Studio Max has a slight advantage in that you can put specific light meters. So if we look at this image, in 3D Studio Max you can actually put light meters into the building and it will give you an exact reading. Now, we've dropped that off this module because it felt like a lot of learning to start to learn an entirely new piece of software for a relatively small amount of simulation benefit. So I'm not showing that anymore. If you do want to get into 3D Studio Max, if you look on my YouTube channel, there are some videos there about how you can get Revit into 3D Studio Max and run simulation. Okay, I don't really recommend it unless you already have 3D Studio Max skills or you're really interested, because in a module like this there's only so much we can cover, and I don't want to overload you with a new piece of software which is an entirely new environment, quite complex, and not really essential. I'd rather that you get your skill level developed in Revit rather than adding something else. If you're interested, look it up on my YouTube channel. Okay, right. So this is what we want to do, and I'm just going to show you a few examples of what we can't do and where people sometimes go wrong. Okay, so if we look at, just open this. If we look at this view here, this is a view of one of our sample buildings, and it's got the kind of top level has been chopped off. Okay? Okay, so there's our building with the top level chopped off using the section box. and it gives you a really good image of the building, three-dimensional, giving you a good view inside. Now, if you then take that corresponding view and you run a daylight simulation, then this is what you get. And if I just put that key on as well, you get a completely false reading, okay? And what Revit will do, it will actually simulate the building as if you have chopped the top of the building off, okay? So for example, if you look at the top of these tables here, they're yellow, indicating a 100% daylight factor, because they're outside, effectively. By chopping the top of the building off, you're effectively simulating the roof of a building. So this is no use to us. For daylight simulation, no use whatsoever. So don't make that mistake. I have seen that done where very completely meaningless results have been achieved by using the section box to chop the top of the building off. So that is no use to you. This kind of view is fine in terms of explaining a project, demonstrating the rooms, demonstrating the spaces. It's absolutely fine for that. But the daylight is of no use whatsoever. And if we zoom in here a little bit, we're getting a daylight rendering here, but again, it's as if it's on the roof, so you've got full sunlight into that room. Okay, so that's not going to help us very much. Let's go back into Revit. And what we need to do, we actually need to work with the camera, and we need to place the camera in a room so that we get a view and a daylight simulation of that room without chopping the top of the building off. Now, equally, if I just open a plan here, there's our plan. We've got our shadows on. A normal floor plan in Revit is also giving you a false simulation of shadows, because, again, in that floor plan view, the shadows, so shadows off, shadows on, the shadows are simulated as if that building is chopped in two with the top taken off. So equally, that will not give you a meaningful simulation of the shadow path in a building. Okay, this all sounds a bit of a problem, but actually it's quite simple to get around it. Okay, so let's go through the exercise. So what we're going to do is we're going to try and simulate the daylight in this level of the plan. And in this example file, this level is called level 10. It's actually the ground floor level of this building, but we called it level 10 because our site is at a higher elevation. Okay, so first thing to do, rather than starting to edit our primary plan view, let's make a duplicate copy of it. So go over to your level 10 view, right click, duplicate view, and we get three options: duplicate, duplicate with detailing, duplicate as dependent. Duplicate will simply duplicate any three-dimensional information. So only the three-dimensional model will be duplicated. Duplicate with detailing will also duplicate the three-dimensional model, but it will also duplicate any annotations. So if you've added any text, any notes, any lines, any hatches which are not three-dimensional, they would also be duplicated. Duplicate as a dependent is very useful. It will make a view, duplicate view, and the two views will be linked. So if you change one view, the other view will change. And this can be very useful. Okay. Now, for our purposes today, we're just going to make duplicate with detailing, and it will duplicate that view, and it will look exactly the same. So we'll do that. There's our view. First thing to do, it's very easy to forget, is rename that view. So by default it's called level 10 copy 1. Let's give it a name that means something to us. So right click, rename. Let's call it level 10 daylight factor analysis. Okay, we should be back recording now. So there's our view. We renamed it Daylight Factor Analysis 2016, just to give it a meaningful name. Okay, there's our view. And okay, what we're going to do is we're going to place a camera into that view. And there's just a few things with placing the camera which are a little bit fiddly, quite easy to make a few mistakes here, but we'll walk through it. First thing I'm going to do is just switch the shadows off because they're not really helping us much. And what you might notice if I zoom out a bit is that this plan view has been cropped. Okay, your little crop tool is down here at the bottom. Do not crop view. If I uncheck that, then we get the whole view again. But that cropped view, if I just put that back on again, is very useful because it means if you're working inside the building, you don't need to be constantly viewing the whole exterior of the site. It's only cropped in this view, so any shadows will still be cast by surrounding buildings. Okay, so we've got our floor plan, and we need to place a camera. So we go into 3D view, camera, and as we've done before, we get that little camera icon following our mouse, and there's just a few little steps that you need to do now, and it's quite easy to get them wrong, to forget what you're doing, and you can make a mistake, but it's easy to reverse it. First thing to look at is look in this top left-hand corner, perspective. Okay? By default, the camera is a perspective camera, so giving a sort of realistic view of the room. If you uncheck that perspective view, your camera will no longer give you a perspective, it will give you an orthographic projection. So it'll give you a straight on, could be a straight on plan, could be a straight on elevation. Okay, so you need to uncheck that. If you don't uncheck that, you can change it later, but it's much more difficult. So check that, click to place the camera, and you have to click again to place the target of the camera, even though it actually doesn't matter for what we're doing. But click again, and we generate, let me just close a few things down here. So plan view on the left, on the right is our camera view, and it doesn't look like very much at the moment. Okay, so there's our camera view. Again, let's rename it. So by default it's called it 3D view 11. Right click, rename, let's call this level 10 daylight factor 2016-1. Okay. So we give it a name that hopefully means something to us later. Okay, so we've got our camera. If I just open that camera view, it really doesn't look like much at all. What we need to do is go to our view cube in the top right hand corner, and we need to click on the top. And what that does is it puts our camera view into that top view. And if we click on the extents of the camera, this box here, you can activate that. Click on those little dots, and you can drag your the extents of that view to only show the building. And because we're looking at inside of the building, we're not interested in the exterior anymore. So we drag those constraints, drag those extents to approximately the shape of the building. Okay. And the other thing about doing that is, in fact, I'm going to drag it a bit tighter. When we are rendering this, we don't want to be rendering the outside space. Now, you can always crop those renderings later. Okay, so we've got our camera view. As you can see, it's actually looking at the roof of the building at the moment, and we can change that in a minute. But there's one other little step here which is really easy to forget, but it's quite a useful one, and that's to lock our view. And what that will do, it will lock that camera view so it's always looking down like this. If you then were to move the camera, move the target, it will always be looking straight down. If you don't do that, if you imagine my hand is a camera, and if you're watching the video, this won't mean anything to you. My hand is a camera and my finger is the target. If that view is not locked and you move that target, then the camera will have to change its angle to follow the target. Or if you move the camera, it will no longer be looking straight down. So by locking the view, what you do is you lock it so that if you move the camera or the target, they move together and they always point straight down. Okay, and that's one of these little teeny buttons down here. This one here. If we click on that, save orientation and lock view. So we click on that, and if you now hover back over that, it will say locked 3D view. So we've locked that view. It's quite easy to forget to do that. Okay, we're almost ready, but as we said, our camera is not looking at the right floor level anymore. Because we've positioned that camera, we've moved it, we've cropped it, we went into the top view, it's no longer where we want it. So, activate the camera, again by clicking on the bounding box of the camera, so it's now active, and go into your project browser. Sorry, go into your properties, and we've now got the properties of our camera. 3D view, camera, giving you all the information about that camera. Okay, and this is what we're interested in: eye elevation and target elevation. So we need to get that camera at the right height. Now, in order to do that, let's just open one of our sections, which will just remind us what the levels in this building are. If I just minimize that. So those were the levels in our building. Okay. So our level 10 is at 115 meters. So if we go back to our camera over here, go into its properties, that eye elevation, we want to put that in the space, and normally for a daylight factor, you would be looking at about 850 millimeters above the floor level, because we're interested in the sort of height of a normal workstation or a desk. Okay. So we set that at 115,850. Okay. And our target elevation, easiest thing is probably just to set that at our floor level, which was 115,000. Okay, so we apply that, and what you can see there in our camera view on the right is that we're now in that space. And you probably just noticed there, if I maximise that some of the furniture appeared, we can see the windows, we are chopping through the doors, So we're now pretty confident we've got that camera at the right level in the building. Okay. So we've now got it is still a two-dimensional plan view, but it's a real camera in that building. If we now switch our shadows back on, down here, we now get a realistic shadow pattern in that building. Let's just open, if I open the corresponding plan view, which was this one, let's get rid of that. Two plan views. If I put the shadows back on, okay, if you look, well, the sun's in a different place. Let's put the sun in the same place. So let's put that still spring equinox, 2 o'clock. And this one, still spring equinox, 2 o'clock. Okay, so we've got there, we've got the two views of the same floor level. The one on the left is our unrealistic shadow pattern where the top of the building is chopped off. The one on the right is our realistic shadow pattern. So for that particular time that I've set there, assuming that we have got direct sunshine, that is the shadow pattern that you would see on the floor in that building. And that already is incredibly useful because we can immediately now get a feel for what the kind of shadows are like and what the direct patches of sunlight will be like in that entire floor plan. And we'll look at this again when we come into the shading design later on. If you look at this building at the moment, there's not a lot of shading on it. So all of this glazing here is unshaded, and there's a little bit of shading over here. So we're getting a lot of direct sunshine. In the session later, we'll start looking at applying shading. Okay, so we've got that view. Now, what can we do with that? A very simple thing that we can do now is to export a solar study. And this is really quite a quick tool. If we go, I'm going to hit save, just in case. Just save that. Okay, if we go now, oh, I forgot other thing I wanted to show you. If I just zoom in over here to part of our building, just to have a little look at the detail level settings, which are down here. And what Revit does, if I go back into my plan view, it's just worth, if you've not come across this already, it's just worth having a few minutes on this. What Revit will do is, you can choose 3 levels of default detail level in your views. That you can customize that completely, but that's a much more in-depth process. But what it does is it gives you these very simple settings. Fine, medium, coarse. If we click that back onto fine, then if I just zoom in a bit, at fine level of detail, you get all the detail of what the building is made of. So you see you're seeing the plaster, the blockwork, insulation, air gap, cladding. So you get a much sort of higher level of detail. If I go over to that door, for example, you're seeing all the detail of that door. If we switch it to medium, you see less detail. There's still quite a lot of detail. You can still see what the wall is made of, but the door is a much simpler graphic now. And then finally, if we put that into coarse, you get just a much simpler view. And it's exactly the same in section views. Okay. Now that is actually a really useful tool. If I just zoom in again, put that back to fine. In a 2D drafting environment, so when we used to work in AutoCAD, for example, with 2D lines, you would often have the situation where you would want this level of detail for a certain view at a certain scale, but then when you came to print this as a 1:200 view, all of those lines just turned into a big blob of ink when you printed, and you end up with this real, really poor quality image where all those lines are just becoming black and useless. And in a 2D environment, people used to struggle with different layers called detail layer and 1:100 layer, and really a real mess. And Revit have really sorted that out, that you can simply, at a very basic level, you can just change the way you want to view that. Really quick and intuitive. Now, in the more advanced settings, and I'm not going to cover it because it's not part of this course, you can actually go into that wall or that window and you can tell Revit exactly what you want to see, fine, medium or coarse. So you can really kind of tune the graphics. But for, to be honest, for most architects working in Revit, they just stick with this little button here, coarse, medium, fine. Normally that is all you need to know. Now, for our purposes, if we go back into our plan view, because we're interested in daylight simulation, we're not concerned about the makeup of that wall. So I'm just going to leave that on coarse, which will give us this kind of view, perfectly fine. Looks like a building. Doors don't have any detail, but we're not interested in that. Okay. So that was quite an important one. Now you won't be able to, you can't use those tools when you're in a camera, because a camera is more like a sort of realistic rendering, so it won't show those graphics. Right. So, solar study. If you come down to the bottom here, to your little sun icon, and go into sun settings, and we get some options, we've looked at these before. Obviously you need to have the right location in the world. I'm sure by now you will have set that, but just check you're not in the wrong part of the world. That's quite important. And if we put this into single day, then we've got a number of options down here. Solar studies, winter solstice solar study, in session single day. Any of these we can duplicate and customize, but I'm just going to keep it quite simple. Let's have a look at the spring equinox solar study. And what Revit is going to do now is simply move that sun around its path, give you those shadow patterns for the spring equinox. And if you look over on the right, we changed over here slightly, so we're on the 20th of March, and at the moment we're going to simulate from 9 o'clock in the morning through to 5 o'clock in the evening. You can change that, sunrise to sunset, and if we change that, it will plot all of the hours of the day where the sun is above the horizon. I'm going to leave that. We can then tell it how frequent do we want to run this simulation. 15 minutes, 30 minutes, 45 minutes, 1 hour. To be honest, normally an hour is perfectly fine. We're not really looking at the level of detail of every 15 minutes. So we'll leave that for an hour. Ground plane, this will cast a shadow on our ground plane in the model. We don't need that. So we've done that. Let's click on apply. Okay. It doesn't immediately appear that anything has happened. What it's actually done is it's moved our sun round to the start point. What you need to do is come back down here to your Sun button, click on Preview Solar Study, and we've got some new buttons, new tools appeared up here at the top. And you can either click play, and it will move through those times of the day, or you can manually move the sun around. If we click play, it's a bit too quick, but I'll do it anyway. Okay, so that was it. That was our day. Probably better to do it manually like this. So I'm just tapping on this forward button here, and you can see the time of the day here, and it just moves our sun around the site, around our building for that time of the day. And that, I find, is a really good, quick, intuitive way of testing your design. Now, what you can do in a very simple sense is you can simply use this as an on-screen design tool. So without worrying at the moment about how we export those images, or how we're going to put them into a report, as a designer, you could simply be using this to evaluate your design. What we'll do later on today, we'll put some shading on, and we'll use this tool to start to very quickly evaluate how effective that shading is. So if you look at this, for example, what we can immediately see is once we get round into the afternoon, sort of 3 o'clock, we've got very, very large areas of sunlight penetration. Now, for a cafe, that may be fine, but if you're in a seminar room and you're trying to work on a computer, or you're trying to watch a projection, and you've got this level of sunlight penetrating into the building, you're probably going to have problems with glare. So that's a really kind of quick tool for assessing sunlight penetration, and also shadow patterns. If you're interested in the kind of what shape of shadows are you getting in your building, well, this gives you that level of information very, very quickly. Okay, let's say we want to export that view. In fact, what I'll do first, I'm just going to go back and change the settings just to show you that. If we change it now to a 15-minute time interval, and we now run the preview, because we've got more frames, we get a slightly slower projection throughout the day. Okay. But I'm going to put that back to 1 hour here. Okay. And we'll now export that solar study. I'm just going to hit save. Okay. Go back up to your Revit button. Export. Scroll down a bit. Images and animations. Solar study. And we get another dialog box. You can customize which frames you want to see. I'm just going to leave that on all frames. You can customize, if you were making a video, how many frames per second do you want? So you can effectively slow your video down. Visual style is all of your normal Revit display styles in the view. Hidden line, shaded, realistic. I'm just going to leave that on hidden line. The dimensions of the export, so just simply how many pixels do you want? I'm just going to leave that alone. Zoom, leave that at 100%. You can add a time and date stamp, which I'm going to add, and what that will do is on the images or the video, it will put the date and the time, okay, which is quite helpful. So click OK, And we have another dialog box. I'll just put this on my desktop. It's helpful to make a new folder for it. If you don't make a new folder, because we are going to export images here, you end up with lots and lots of images. All right. Come down to the bottom, you can rename it, and you've got some options. You can export it as an AVI, which is a video file, JPEG, TIFF, BMP, GIF, PNG. I'm just going to have JPEG. Okay. You've got some options here. Sorry, that takes you back to the options you've already looked at. I don't personally find the AVIs very helpful. It creates enormous video files, huge video files, and I prefer just to have the images generally. So click Save, and Revit will now export, goes through that solar study, and it's exported those images. So if we just, let's just go and find those. On my desktop. Solar Study 1. So there are all the images. So that's what they look like. Okay. The date stamp, it's not the most graphically pleasing thing, so you might want to switch that off, but it's quite helpful for reminding you what you're looking at. And as I just scroll through those images, we've just got a very simple export of what that sun is doing. Okay. So that is quite useful. It's not the most sort of sophisticated rendering. It's just a sort of white or grey, but really useful for showing you where the shadows and the direct sunlight is in that space. Okay. Back into Revit. We're going to have a break in just about 6 minutes, okay? Let me just check my notes. Okay. Right. Stick with me. We'll have a break in just a moment. Right. Okay. What I'm now going to do is we now want to do a daylight factor. Please. We're going to do a daylight factor simulation. Okay. What I'm going to do is go back into our sun settings here, and rather than having it as a solar study, I think I'm just going to set that as a still. And let's set that at the spring equinox, 2 o'clock. So we're not now looking at multiple sun positions. We're just going to look at one for the time being. Okay, so we've set that to that moment. And the way we now do the daylight factor is exactly the same as we did it with our 3D view. So we go up to View, Render in the cloud, and we can just click Continue on that. Okay, it's a bit tiny there, a bit difficult to see. Which 3D view do you want to render? Now, by default, if you've only got a single view open on your screen, Revit will choose that view for you, which is helpful. Otherwise, you have to go into this dialog box, choose the correct view, or choose multiple views if you want. Okay, we've done that. Output type is illuminance. Okay. Image size, I'll set that at 2.25 megapixels, which is okay for us. If you were doing this with lots of time, you could set that larger. Okay. Then use date from view. We saw this before. Let's select that. Rather than customizing it from the date which we type in here. Let's just choose the date from the view. Sky model, daylight factor sky. Exactly the same process as we looked at last week. Legend. The legend is on your colour scheme. What percentage will it colour code? Is it 0 to 100? Is it 0 to 10%? 0 to 5%? You can click that on automatic, but I tend to like to stick to more defined values. For this building, because I've simulated it many times, I know that we're actually getting quite strong levels of daylight at the moment. So what I normally do is start this with, say, 0 to 20%. And that first simulation will colour code it 0 to 20. You can always go back in and re-simulate if you want to change that legend. Okay, so we're ready to go. Start rendering. I know there's a missing JPEG in this file. I think it's off one of these pieces of furniture. So we'll get that, we should get that warning message in a moment just to say JPEG is missing. Yeah. So the following render appearance image is missing. I'm pretty sure it's just the sofa, that when I've imported the family of that sofa, I've not linked it with the image. But we can just continue. It's not going to make any difference. Continue in the background. Okay, so that has now been sent. Okay, that's gone off into the cloud. Now, what I'm going to quickly show you before the break is not that. How to then produce this kind of rendering, which is a kind of realistic daylight factor render of your building with real materials. And that really is very simple. Go back into render in the cloud. Again, choose your view. Output type this time is still image. Choose your size. Okay, exposure, advanced or native. I just generally leave it on advanced. File format, you can choose what kind of file format. And let's send that to render. That's okay. Continue in the background. And what that will do is, over the break, that should render two results very much like this. The first one giving us a daylight factor analysis of the whole floor, and the second one giving us the corresponding sort of visualization of that floor level with materials, with shadows. Okay, so we'll leave those to render. We've got a 20-minute break, and then we'll start again.